let's do some practice here. We can use our rule to start and see if we can confirm our rule, but our rule again was top times top, so 3 times 2 gives us 6 pieces that make up the parts, and we had 4 times 3, which made up the whole pieces. Okay, so it looks like we should get 6 over 12 or 1/2. So let's check this out. Okay, so I have the number of pieces that make up 3/4. So I'm going to do 3/4 along my horizontal, so 3/4. Okay, so 3/4 is that piece there. So I'm just going to shade that, and I'll just do some color to shade that. Okay, so 3/4 ends up there. 2/3. Okay, so I'm going to do this in thirds. 2/3 along the vertical is going to end up there. Okay, so I'm going to shade that part here. So this is my length. That's my width. Okay, this represents the area that I want. Okay, so this must be the answer. Okay, so how did I get this answer? How many pieces do I need to count for my numerator, or parts? 1, 2, 3, 4, 5, 6, or 2 groups by 3 groups, or 6 here. I need to figure out how many pieces make up the whole, which is the whole square. So I have 3 groups this way to make up the whole, 4 groups this way to make up the whole, so I have 12 groups in total. Yeah, that 12 makes perfect sense. Okay, so it looks like it's 6 over 12. So I did 4 times 3, and I did 6 times 3 times 2 to get the 6. So top times top, bottom times bottom seems to work. And again, if I just take a look at this, well, I can easily rearrange this into 1/2. If I take these two pieces and put them up here, okay, get rid of this. Oops, I shouldn't do that. Okay, I just want to get rid of this shading here. Yeah, that looks like, yeah, that's definitely 1/2 fraction. So 6 out of 12, I can simplify to a 1/2 fraction as my answer. Okay, excellent. So what about this one? This is a mixed or improper fraction. It's a number bigger than 1. So how can I make this work? Well, the 1 still represents, 1 by 1 still represents 1 whole. So where would 3/4 be? Okay, so let's see, 3/4. Well, I'm going to do thirds, so I'm going to do along the horizontal, thirds, 1/3, 2/3, 3/3, but I got to go outside that to measure one more third. Okay, so that's 4/3. Okay, so I'm just going to draw that a little bit nicer here. That's going to be 4/3, and then this will be 5/3. So I've divided up this number line into 1/3 pieces. Okay, so that's right. Yeah, that looks good. 3 pieces to make up the whole. And 4/3, so I need this length all the way to here. Okay, so that's my length. So what about my width? I'm going to have 3 halves, so my divisions are halves. So I'm going to have to go half, 1/2, 2 halves, 3 halves. That's 3 out of 2 pieces here. Okay, so it's gone past my 1, but the 1/2 divisions is correct. So I divide the one whole into 2 parts. Yeah, half, 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 half. Everything goes up by halves. So this must represent my area. Okay, so I'm just going to shade my area. Okay, I need to go 4 pieces this way and 3 down. Well, that still seems to confirm that the numerator times numerator gives me the number of pieces I'm shading, right? That's what I'm counting. Okay, so it looks like I have 12 pieces that I've counted here. 1, 2, 3, 4. 4 groups this way, 3 groups this way. My numerator times numerator. I still need to work out my whole. Well, how many pieces make up the whole? There's 6 pieces in here. And again, it's still consistent. I divided this whole into 3 parts horizontally. I divided the whole into 2 parts horizontally. So I have to have 6 parts that make a whole. And if I simplify that, really I just get 2 whole squares. Well, yeah, that seems to make sense, because if I take away the shading here, 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 those are 4 pieces. and I just shade these 4 pieces, yeah, I can easily make 2 whole squares. Okay, so I'm just going to leave my answer as the other way around, just because, you know, we actually generated this answer of 2 by doing 1.5 vertically, okay, times 1 3/4 horizontal. There's 1 1/3 horizontally. It gave me 12 pieces out of 6 parts whole, which gives me 2 whole pieces. Okay, so this area model is an excellent way to justify or to do multiplication, any kind of multiplication. It seems to confirm this nice new rule as well of top times top, bottom times bottom, because the top times top seems to give us the number of pieces I'm going to end up shading, and the bottom times bottom, in this case 3 groups by 2 groups, seems to give us our 1 whole, or the divisions that make up the 1 whole piece. So this is going to be the way we're going to visualize multiplication. This is easier than our other method. Okay, now we can use all sorts of visuals. We should be flexible, but this is going to be an easy way to justify fraction multiplication and why we can do top times top, bottom times bottom. So I'm going to show you some apps here that we can take a look at and visualize these same multiplication models.